This is ASTROS training, and ASTROS stands for Automated Structure Optimization System. And we have 12 chapters to talk about ASTROS. The first chapter is overview of ASTROS. And what is ASTROS? ASTROS is a multidisciplinary design optimization environment based on the world standard NASRAM format that combines the finite element analysis (FEA) with the efficient optimization solutions to deliver significant reduction in the time required to develop a superior design of aerospace structure. ASTROS was originally developed by Northrop Grumman and the Universal Analytics Inc., supported by U.S. Air Force. ASTROS is a FEA-based MDAO tool used to support both preliminary design stage of new aircraft and the spacecraft structure, and the design modification that occurs later in the product life cycle. And ASTROS integrate all of the engineering disciplines that impact the structure design. For example, so at the center of ASTROS is a structural finite element analysis module. Then you have a aerodynamic module, and to create steady and unsteady aerodynamic forces. And you have trim module, and you have a sensitivity analysis. You have a flutter module, and you have a unbuckling, a strength analysis module. Then you have an optimizer, which is based on so-called gradient-based optimizer. And why we want to develop ASTROS? Because ASTROS allows for maximum impact at the preliminary design stage of aerospace structure design, and the stage at which the configuration has been defined and the materials have been selected. The design task is the determination of structure size. For example, the thickness of the skin that will provide an optimal structure while satisfying numerous requirements that multiple disciplines impose on the structure. ASTROS can shorten the design cycle time and provide better structure design, and particularly true as the composite material came into widespread use. This is because, unlike the isentropic material, the thickness of each element is a design variable. But for composite material, so for example, you have 16 layers, then each layer, the thickness of each layer become a design variable. Okay, so for the composite design, a composite structure, and the number of the design variable increases drastically. And also ASTROS can find the balance conflicting requirement for strength, stiffness of structure, while exploiting the benefit of anisotropic like area steering is perhaps an impossible task without assistance from an automated design tool. If you want to take advantage of aeroelastic tailoring, and by designing an optimal composite structure to satisfy the design constraints, and without automated design tool like ASTROS, to find such a optimal structure almost impossible. The use of a single tool can also bring the design task into better focus among design teams members, thereby improving the insight into their overall task. And with a larger MDAO framework that make use of the latest CAE tool technology like a model center, also can effectively be used to handle the structure sizing. This is architecture of the ASTROS system. So you have ASTROS software system. You have several input files. Of course, you need a ASTROS license server, and you have input file, and you have preference file. You have a permanent database. This and the preference file and the permanent database will be automatically installed while you are installing ASTROS software and the installation software will automatically put the preference file and the permanent database called astros.edb, astros.00 in the home folder of ASTROS. And while you are running ASTROS, and you have to define a runtime database using assign runDB in the input file, and then you will will create a runtime database. If your input file is called myjob.d, and the name of the database will be called myjob.edb and myjob.00, myjob.01, and so on. And ASTROS, each module of ASTROS will create a new data entity, and this new data entity will put into the save in the runtime database. And the next module can retrieve this data entity from the runtime database. So among each module of ASTROS, they do not talk to each other directly. Rather than they retrieve the data entity from created by previous module and generate new data entity and put into the runtime database. And the runtime database name is called myjob.00 and myjob.edb. Of course, you have a standard output file called myjob.prt, and you have a log file, which documents the CPU time of each module. If we want to output the optimized structure in terms of the property class of each element, and you can then you have this myjob.pch. Also, you can output several graphical files, for instance, to display the aerodynamic model, the unsteady pressure, flutter motion, and intermittent motion, and so on. And there are three sections are required by ASTROS. The first we call a resources section, and you have to define you have to use assign runDB equal give a name of the database, and you may specify the memory, and then you have a solution control section. In solution control section, you can define if you want to perform our optimization or do analysis. They're all specified in the solution section. Then you have bulk data car section, and you have to use end data to end this input file. And this is an example of ASTROS input file. And you say assign runDB equals myjob. Okay, so you create myjob.edb, myjob.00, and then there's a command called dlog, and for 32-bit computer, the maximum size of each runtime database is 2 GB, which may not be sufficient for a large size problem. The dlog command allows ASTROS to create multiple runtime databases. So you say dlog equals parentheses dot backslash common dot. So each dot backslash will create one runtime database. So you have a 3 dot backslash. Then ASTROS will create myjob.00, myjob.01, myjob.02. So you create 2 GB runtime database. Then you have to specify solution within solution, and you can say you can perform optimization. You say optimize, and you define several parameters for the optimizer. We will talk about what's the meaning of those parameters. And within the optimize section, you can define multiple boundary conditions. For example, if you have a high half-span structure model, and you have a symmetric boundary condition and anti-symmetric boundary condition, and within each boundary, you can define multiple discipline to be performed. Like, for example, you have flutter, static, analysis, and this one you have flutter and S arrow to perform trim analysis. After the optimizer determine an optimized structure, you can specially analyze to perform thorough analysis to verify that the optimized structure satisfies all constraints. And after that, you have a bulk data section. And how to run ASTROS? Very simple. You just say ASTROS and you specify the input file name, and then we have a default purpose file, and this the file it will be installed in the ASTROS home folder while you are install ASTROS to your computer. Inside here, the purpose file defines the default value of many parameters. For example, you have a maximum memory. You can increase this memory for a large size problem. And another one is called auto SBC dash EPS. And this one, if the diagonal term of the stiffness matrix is smaller than this value, ASTROS will remove this degree of freedom from the A set. And this may create a problem, because during the optimization, if all of a sudden one diagonal term of the stiffness matrix is smaller than smaller than this value, and ASTROS the auto SPC will remove this degree of freedom from the A set. So all of a sudden, the size of the A set degree of freedom change. In this case, ASTROS may fail. So if that happens, you have to decrease this default value. The input file of ASTROS must be something .d. Okay, for example, myjob.d. The output file will be in .prt. So you have if the input file is called myjob.d, the output file called myjob.prt. The standard output file containing the echo of input, cost and result of each optimization step, constraints, evaluations, design variables, and analysis result all this discipline. For the converged final structure design. And you have a myjob.log containing the CPU time of each module. If you specify punch in the solution control command, so after ASTROS find out optimized structure, you will punch out the property cars of the optimized structure, like a PCL car, PCOM car, and so on. And also you can output graphic output files. For example, you can use a plot error car to output the graphic file to display the aerodynamic model, plot mode car to display the spline mode on the aerodynamic model. You can you can define a plot server car to display the control surface kinematic mode. And you can use the plot VG car to output the data to display the VG diagram. In the plot VG car, for example, if you say, you define an output file name called vg.dat. The actual output file are vg.i, where I is the index of the optimization iteration. So if ASTROS use 20 iterations to find optimized structure, then you have 20 vg.dat. So it's start from vg.dat1 to vg.dat 20. And also you have runtime database called myjob.00 and myjob.edb. And you can use Rona GUI system called Rona MV to display the design history, including design variables, stress, strains, displacements, mode shapes, weights, spline modes, and the VG diagram at each sizing iteration. To run ASTROS, we will give you a dongle. Then you attach a dongle to a server, and then you install ASTROS in many desktops. If you only license one ASTROS token, while you're running ASTROS, the ZRS will go into the server, check out one token. So before this job is finished, you cannot submit another ASTROS job if you only have one token. If you want to terminate ASTROS job, the better way to go in is to go into the task manager. You select ASTROS bin.exe and you hit end task. Okay. However, for abnormal termination like power failure, that you may encounter so-called lock token problem. Another way to kill ASTROS job is just use Control C. You can terminate ASTROS job. While you're running ASTROS, if you close up the window, you may also encounter the so-called lock token problem. How to release a lock token? You can go into the ZRS under the ASTROS home folder and go to the lock folder. You'll find a executable code called cleanup.exe on Windows and cleanup on Linux. And you run this code, and this code will release the lock token. And if this code cannot release the lock token, you can restart the server, and the ZRS will release all the lock token. And the leftover token that are not checked back into a ZRS after you restart the ZRS can be deleted manually as they are no longer needed. The files are located in the ZRS/log folder and appear as the following file name.